So we all came together in March of last year when we were all going to die in April, as we were all discussing just now. And one of the things that we noticed when we all were getting together was in the surge in New York and in the surge in Italy, there were doctors were using whatever they could get their hands on to save people. And so from that grew the Tetra Biodistributed Group. So Jamie's going to talk through the splitter, which was how can we do that safely? But then as the splitter work continued to drag on, and we were having a really hard time making that across the finish line because it turns out it takes a bit of time and energy and effort to make a medical device from scratch. We pivoted to actually including two other devices that our clinical advisors told us would be actually just as, if not more impactful. And so we started working on a PAPR and a fitment device. So Jamie's going to talk first about the splitter, its genesis, and where we are now.
So hi, I'm Jamie. I've been with Helpful for about a year now, and I'm the project manager for Tetra. So who are we? Project Tetra is an ambitious project to design an open source ventilator splitter with flow control built in. We're a team of about 10 to 15 people based across the US and the UK who've been working for a year to make Tetra a reality. We've designed and tested many iterations of the splitter using 3D printed components and working with clinicians to understand what is needed to make Tetra safe and usable in an emergency situation. We've also explored the regulatory requirements surrounding this device in both the US and the UK. Our ambition has always been to get this device into the hands of doctors as soon as possible, while negotiating the regulatory minefield and keeping patient safety at the forefront of our work. This balancing act has now led us down the path of using off-the-shelf components to make the road to approval as short as possible. On the slide, you can see one of our designs, which is in the bottom left, and above it is one of the early prototypes of Tetra with the 3D printed parts. It was a year ago when the idea of a ventilator splitter first occurred to me. And without Helpful, I wouldn't have been able to build a team of amazing and devoted people so quickly. Helpful provided a vibrant and dynamic Slack community in which to start the project and grow the team to what it is today. The team has gone on to do amazing things to drive Tetra forward with specialist support from Helpful in a few key areas. One of the most crucial things Helpful has done for us has been organising fundraising on behalf of Tetra. This money, generously donated by you, has allowed us to build many more prototypes than we could have built by ourselves. Helpful has also provided opportunities for cross-project collaboration, allowing all of the ventilator teams to learn from each other, and this has been invaluable to the development of Tetra. Thanks to Helpful for all the support so far and in the coming months. So what's next? Soon we hope to get our latest prototype tested here in the UK before moving forward with the regulatory pathway in both the US and the UK, seeking FDA and CE approval respectively. Concurrently, we'll also be offering this device to Central African countries through our partner in the UK, 3D Crowd. We're looking forward to clearing all the regulatory hurdles and finally being able to offer this device to the clinicians who need it.
The FITRA, as you can see here, so we provided GitHub links to all of our projects, so you can download all of the source and all the history. In this case, the FITRA is, we have a lot of design history that is all essentially irrelevant. The fitment device that is at that link is something that you can print with a resin printer. The idea is that this fitment device, you can see here being modeled by Daniel Stemmen, who's the head of respiratory therapy at USC. This fitment device takes that Honeywell mask and transforms it from being N95 material, but not actually protective, into something that is actually protective. And the hose that is coming out of the mask is for a device called a port account. The port account is for the NIOSH quantitative particle testing. So most N95 fitment devices, fitment tests have been done in qualitative means, meaning that you put somebody's head in a bag and you squirt perfume in it and you see, can you smell the perfume? Well, this is a problem if somebody's sense of smell has been obviated by COVID. So what they've decided to do is to start looking at the quantitative testing protocol, which is what the port account provides. And so with the quantitative testing protocol, Daniel was showing that Honeywell masks and BYD Care masks were simply not performing up to N95 standards. The material was there, but the fit was not. So we designed this fitment device, Burhan Kadumi on our team and a bunch of others with a bunch of modeling to try to come up with what the appropriate contour would be on the face using the NIOSH head form standards. And what we found was that you can see here, this graph is a little bit busy, but what you can see is that we tested 6 different scenarios using the 3M masks, the BYD Care mask with and without the fitment device, and the Honeywell mask with and without the fitment device. And it's color-coded with green being the most successful and red being the least successful when comparing to overall fit, which is the last cluster of bars here. And what you can see is that when looking at normal breathing, deep breathing, head side to side, head up and down, so on and so forth, the 3M standard 1860 mask is extraordinarily performant. And the 3M 8511, which has been authorized for emergency use, is also performant, but not as performant as the 1860. Unfortunately, 3M did not increase production to match the needs of what hospitals were looking for and first responders and everybody. Companies like Honeywell and BYD Care stepped up to produce many more masks. But as I said, the material may be N95, but the fit is not. And so what this is doing is actually taking the orange and red graph, as you can see there, where there is actually very poor fit, and translating into being as performant as the 3M mask or more performant as a 3M mask. You can see the number of N there. So we're hoping to expand this to many more people, but also this is a $3 part. So we're hoping to get $3 parts out into the world to any first responder for anybody who needs N95 protection, not just for coronavirus, but for any other future problem where you're going to need this type of protection. So that's Project FITRA. This graph should be published shortly in the Journal of Occupational and Environmental Medicine. I think I got that right. It's under review right now. So alongside of that, we wanted to actually make a PAPR, because one of the big complaints that people have with N95 masks is that you're wearing them for 8 hours a day, and they can be extraordinarily uncomfortable. And so we wanted to make a PAPR, and what you see here is what we need to build a sub $100 BOM cost, bill of materials cost, for a PAPR. And this PAPR is also N95 compliant, using the same port account testing protocols. All the parts here are all what you need. What we've provided on our website, on the link above, we have several different projects. We have one project for the print, one project for the circuit board, and another project for I think we have a project for the firmware, but definitely another project for the documentation. And so in those projects, we describe how to actually build all the components, what the bill of materials is. And we have actually done this several times. We're looking to have another build party, what we call the build party, on Saturday, where we make 3 or 4 of these devices, and then we test them, and then we give them to volunteers. And so one of our volunteers right now, for instance, is testing this as a running belt. So what she's doing is she's taking this device and strapping it to a MOLLE belt, which is, I can't remember what MOLLE stands for. Jamie, do you remember what MOLLE stands for? I can never remember it. It's a
modular attachment system that's used by the military.
Yeah, that. So you strap it onto a belt, and then you can actually go running for, take a 5-mile run. And that's really important for those of us who live in areas with pollution and bad air quality, like Southern California. We're about to go into fire season. So again, this is a device that has implications far beyond coronavirus of being able to just simply walk around and breathe clean air, HEPA filtered air, which is N95 compliant. You can see another assembly diagram here where we actually built and designed our own circuit boards for the M12 battery controller, but you can just buy an off-the-shelf M12 battery and use that as a way of charging this device. So you can continue to walk around, and if you run out of battery, just swap it out. Filters, are good for a month, 3 months, depending on how much you use them. And the filter material in the mask is actually just a surgical mask that's been cut up. And again, that's N95. You just don't want to wear a surgical mask directly pushed onto your face for very long. It provides a lot of friction, and it's extraordinarily uncomfortable. So that's the plan here, is to produce a comfortable, cheap device that would give people fresh, clean air. And so those are the projects that we've been working on.